This video is about applying the properties of kites. So remember that a kite is a quadrilateral, which is a four-sided figure with exactly two pairs of consecutive congruent sides. So in a kite, we have two sets of sides that are congruent that are going to be next to each other. That's one property of a kite. The other properties of a kite are that the diagonals are perpendicular. So remember the diagonals go from opposite vertex, and they are perpendicular, which means that they form right angles. One pair of opposite angles is congruent. The opposite angles that are congruent are always going to be the angles that are between the two different sizes of our sides. So in this case, with the kite laying on the side, the up and down angles. The shorter diagonal is bisected. So the shorter diagonal is always going to be the one that passes through the congruent angles. And then the longer diagonal is going to bisect the angle it passes through. So we have angles over here congruent and these angles congruent. Now, the angles that are bisected are not congruent to each other. So the angle on the left over here is not going to have the same measure as the angle on the right over here. So let's use this idea to find some missing angle measures. So find the missing angle measures. So notice that 132 is between the two different sized sides. So the other angle across from it is also going to be 132 degrees. To get our last angle measure then, we know that any four-sided figure always has 360 degrees, so we're going to do 360 minus the angles we know. So minus 132, minus 132, and minus 87, and we subtract all those, we get 9. So this angle is 9 degrees. Number 2, notice that the angles between the two different sides are 120 and 15x, so we can use that to solve for x. So 15x equals 120, divide 120 divided by 15, and we get 8. Once we know our angle measure is 8, we can substitute. So we know this angle has to be 120 because 15 times 8 is 120, and 9 times 8 is 72. Then to find our missing angle again, all we have to do is subtract from 360. So 360 minus 120 minus 120 minus 72. And we get that this angle is 48 degrees. Now, 3 and 4, we have diagonals, so they're going to break up the angles a little bit. So remember with a diagonal, that first the angles in the center are 90 degrees because our diagonals are perpendicular. So it creates 4 right triangles, 2 of which are going to be the same. So we have 2 littler triangles and 2 more stretched out triangles. So on the triangles on the left, remember that the longer diagonal is bisecting this angle, so they're both 29 degrees. So to find the missing angles in those triangles, we can do 180, looking at a triangle. So we can do 180 minus 90 minus 29, and we get 61 degrees. So 61 degrees is going to go in both of these triangles because they're both congruent right triangles since they both had a 90 degree and a 29 degree angle. Then in our other triangle, if this is 71 and these angles are bisected, we can do 180 minus 90 minus 71, and we get this is 19 and 19. And then I know the angle that's still missing has to be 71 degrees because these two triangles are congruent right triangles. So number 4, let's do the same thing. In the center by the diagonals, those are perpendicular. The longer diagonal is bisecting this 13-degree angle into 13 and 13, and the other angle into 66 and 66. So to find our missing angles, we can just subtract from 180 for the triangles. So in the first triangle, we have 180 minus 90 minus 13, which gets us 77 degrees in both triangles. And for the other missing angle, 180 minus 90 minus 66, and we get 24 and 24. ABCD is a kite with shorter diagonal BD. Solve for x and y and find the perimeter. So remember that BD is the shorter diagonal, so the property is that it's bisected. So both of these pieces are 9. Also remember that our diagonals are perpendicular, so we have 4 right triangles. So whenever you're looking for a missing side and you know 2 of them in a triangle, we're going to be doing Pythagorean theorem. So to solve for x, we have x squared, because x is across from the right angle, so it's the hypotenuse, equals the leg squared plus the leg squared. So we get x squared equals 144 plus 81. X squared equals 225. When we take the square root of 225, we get x is 15. So remember that the consecutive sides that are next to each other that are congruent, so if this is 15, AD is also 15. Then we're going to do the same thing solving for y, because y is going to give us CD and BC, because these are my other 2 sets of congruent sides. So to solve for y, we have y squared equals 9 squared plus 40 squared. 9 squared is 81 plus 1600. Y squared equals 1681. And when we take the square root, we get y is 41. Then the last step here is we need to find the perimeter. So the perimeter, we add all of those sides on the outside together. So 15, 15, 41, and 41. And we get our perimeter is 112. So let's try looking at another one in number 6 where we're doing the same thing. So to solve for x, we know that BD is our bisected diagonal and that the diagonals are perpendicular. So to solve for x, which will get us AB and AD, because those are the congruent sides that are consecutive, we have x squared equals 6 squared plus 8 squared. X squared equals 100, because 36 plus 64 is 100. When we take the square root, we get x is 10. So we have 10 and 10. Then we know that BC and CD are congruent because they are the other set of consecutive sides, but I still need to find y. This time, y is not a hypotenuse because across from the right angle is 17. So to solve for y, we're going to have 17 squared equals leg squared plus leg squared. 17 squared is 289 equals 64 plus y squared. Subtract 64 from both sides. 225 equals y squared. When we take the square root, y is 15. Then the last step we need to do is find the perimeter. So to find the perimeter, I have a side that is 10, another side that is 10, a side that's 17 and 17. So the perimeter is equal to 10 plus 17 plus 17, which will get us 54. Determine the following statements are sometimes, always, or never true. So sometimes means that it could happen in some shapes but not happen in others. It always means that that statement's always true, so like a property of a shape. And never true means that it's either not a property of the shape or 2 different shapes that have no type of relationship between each other. So in number 7, trapezoids have one set of congruent sides. So remember, they only have congruent sides if it's an isosceles trapezoid where we have congruent legs. So this is a sometimes. Kites have perpendicular diagonals. This is always true because that's a property of kites. In a trapezoid, base angles are congruent. This again is a sometimes because the base angles are congruent if it's an isosceles trapezoid. If it's a regular trapezoid, then they're not. Number 11, a square is a parallelogram. So remember that squares always have all the properties of parallelograms, so this isn't always true. A rectangle is a trapezoid. Well, remember that a rectangle has 2 sets of parallel sides, and a trapezoid only has 1 set of parallel sides, so this is going to be a never true statement. Trapezoids have congruent diagonals. So the length from one opposite vertex to the other is congruent to the other one. This sometimes happens if it's an isosceles trapezoid only, because remember, regular trapezoids, the only property is that the consecutive angles are supplementary. A rhombus is a kite. This is never true. They don't have all the properties in common. A rectangle is a trapezoid. We already said again that that one was not true. And a parallelogram, the diagonals bisect each other. Remember, that's a property of parallelogram, so this is always true.